Good morning. Good morning, Webit. I see you all still have some energy left, so welcome to this presentation about how commercial drones disrupted GIS, mapping, and agriculture. To start, let me give you a very quick introduction about senseFly and what senseFly is. So senseFly is a company that has been founded in 2009, so we've been around for 10 years. So 10 years in the history of the world, that's a very short period of time, but in the history of drones, that's actually quite a long time. We're based out of Lausanne in Switzerland, but we have offices all around the world. We have over 200 points of sale globally, and we are the #1 producer of fixed-wing commercial drones. We work for, I would say, many of the very big organizations worldwide that are interested in getting accurate data, getting accurate mapping. And how we do that is with this. This is EBX. EBX is the latest of our flagship product, the EB. The EB has also been around since 2010, 2012. And it's really the product that has changed the way people do large-scale mapping, do large-scale GIS, and it has changed the way people do surveying. So let me put this down for a second so I can give you my full attention. The EB basically flies over large areas of ground and captures data to convert this data into 3D models that are highly accurate and that are used by surveyors, that are used by mapping offices, that are used by large companies that are interested in getting accurate data, like mining companies, on how really their land looks, where the material is, and where the borders of certain specific terrains are. So let me show you some of the outputs that we produce. Sorry, that went one too far. Here you go. So that's one example of a point cloud that was taken near a dam in Switzerland. And as you see, it is really an accurate representation of the terrain that has been mapped there. Here we have another example of a hotel complex, I believe somewhere in South America. And as you see also here, you have a very accurate representation of the roads, of the buildings. You see every point in a very high detail. And bear in mind that every point that you see on this, we call it a point cloud, every point that you see on this point cloud represents reality with an accuracy of approximately 2 to 3 centimeters. So it's very precise, and it's used by architects, by construction companies to remodel, to build new designs based on the existing reality. This is another example of a village that has also been mapped with the EB, also a very accurate 3D representation. And to give you an order of magnitude, to map an area like the one you see here on the screen, it takes you about 10 to 15 minutes. 10 to 15 minutes, and that is precisely the reason why when I said, our drones, the professional fixed-wing drones, have revolutionized the way GIS and mapping works. It's because everything has become much safer and much more efficient. Now, you may be wondering, how does it all work? How do you get a small drone like this, that's very light, to get to a very accurate representation in 3D of the reality like the one shown on the screen? So the way it works is with our sister company, Pix4D, that's also based in Lausanne. We have a very strong partnership, and what we do is acquiring the data with the drones. Well, we don't do it, our customers do it. And then we run it through a dedicated software called Pix4D Mapper that will correlate the images that you take and reconstruct a 3D model. It's very similar, actually, in the way it works. Some of you have probably used TVs with 3D glasses. You see one image on the right eye, one image on the left eye, and you get the impression that it's in 3D. Well, here the process is actually exactly the same, just turned around. So you take different images that look at the same area, but from a different angle, and these images are then used to reconstruct the model in 3D. So where it brings really the efficiency here is that in traditional mapping, in traditional land management and surveying, people take measurements of points to points. And then they reconstruct everything, and they have single point measurements which take a long time to acquire. Whereas when you use a drone like the EBX, you get millions of points in seconds because you use very high accurate sensors with the imagery that give you all those points, and you use then the reconstruction of it behind it. So this has disrupted the mapping business, but the mapping business really in its entirety. What we're talking about is the whole surveying business, so land management, really getting accurate measurements of points that help you then to plan, where is the next road going to run, how much earth do we have to move to build a new road, is the terrain adequate for something, things like disaster prevention, because you are able to model how floods will work out, or what happens, for example, if you are in mining and you're gonna start mining another facade of the mine site. Also helps mining companies do what we call volumetry, so really having an accurate representation of their stockpiles and the amount of actually minerals that they have mined. But it's also used outside the classical GIS geospatial applications, for example, in the agriculture industry, because in the agriculture industry you have very similar problems, and you want to understand, how your fields are doing, you want to understand, are your plants growing well, and the data that you can get with a fixed-wing drone, which has a very high coverage, is going to help you do that. So, to the topic of disruption. So what does it mean to disrupt something? It means to make it much more efficient. Not like 10% more efficient, but like 5 times more efficient. And this is the typical efficiency gains that we've seen by asking our customers that they are getting with the EBX compared to the way that they were doing their mapping, that they were doing their measurements before using a drone like the EBX. So we're talking 3 to 5 times lower cost than terrestrial mapping, and obviously much lower cost than mapping with an airplane, because when you get an airplane into the air, it already always costs a couple of thousands of dollars if it's a professional plane to do mapping. This is another example of mapping high-speed rail route. That is also a very common application case that land management offices do. In this case, also we had a 5 times cost saving over terrestrial mapping, and that's really the kind of 3 to 5 times cost savings and efficiency gains over classic mapping is what we see across industries in terms of efficiency gain. This is quarries and mining. Again, the same type of efficiency gains. Much more data, much more accurate data. It is really in some bigger mine sites like that companies like Lafarge, for example, have in Africa. It has really boosted significantly the way they operate and the way they are able to also continue developing their mine site in terms of planning the right routes, knowing how much minerals they have extracted, and knowing exactly where to continue digging next. I also mentioned agriculture earlier. Agriculture is also a field where our drones are being used a lot, especially on very large-scale farms or by big crop companies. And typically what you see here is the ability to, for example, reduce fertilizer application. And reducing fertilizer applications, of course, it's great because it means 3 things. It means you're going to spray less, so your the impact of the nitrogen on the earth is actually reduced, so it boosts your ecology. At the same time, it lowers your cost because when using less fertilizer, that's typically a good thing. And at the same time, you get yield increase out of it because there's area that you would typically fertilize in a big farming operations that actually don't need it. And by over-fertilizing, you increase the crop production. You don't increase the crop production, you reduce it. So these are some of the examples that we've seen and that our customers are using. And so all this revolution has really started, as I mentioned, 10 years ago. when we released our first product. And now let me give you a little bit of an overview where we are today. So our customers have flown over 250,000 hours. There's over 10,000 UAVs or drones like the EBX here that are out there. And I'm not lying when I say that probably 2/3 of these 10,000 UAVs are still operational and flying today, even when some of them are already 10 years old. We have customers that have flown all kinds of areas, including mapping volcanoes in the Andes, where the drone went to fly up to 7,300 meters high. So that's really the altitude at which you only typically see airplanes. And our customers are also active really all over the world. We've literally, we know there have been flights in 183 countries of this world. And on the map displayed here, you see kind of the hot points where people are mapping, including the Antarctica, including some of the most remote places, but also some of the very populated places. Because one of the big advantages of using a very light drone like this is, by the way, this is 1.5 kilograms. So it's very light. And one of the big advantages of having a very light drone like this that can fly for an hour and a half or more is that you can also use it in areas where you might have people around. Because you always have to plan also, what's going to happen if something happens, if the drone gets attacked by a bird, for example, and it comes down. Well, with a 1.5 kilogram drone that has a very low mass density, like the EBX here, the risk of harming somebody is very, very low, and that's very, very important. Because safety at the end of the day is one of the things that we want to achieve by using a drone like the EBX. So we've also been credited with being the most used fixed-wing drone. Of course, there are not only fixed-wing drones out there, people are also using multi-rotor drone, but one of the big advantages of the fixed-wing drone is that it flies longer, and it's really what closes the gap between terrestrial mapping and using mapping via satellites or mapping via airplanes. And typically, where we have registration data available and know what are the different types of drones being used, because most of the organizations like the FAA in the US, they actually ask professionals to register their drones. We're seeing market shares between 40 to 50%, which I would say gives a lot of credit to the success that the EBX has had over the years. So this has been it from my side. Very much enjoyed being here. I invite you to go check out our website, and if you have mapping needs, well, senseFly can help you get the job done. Thank you very much.